Okay, and then we proceed to the next video. It is about column design. Okay, for the calculation of column design, first we need to do the inspection. We need to uh, analyze the specification of each floor, and then first we need to analyze the for the roof floor. Okay, this is my figure plan of roof floor. My critical column is right here, which is column B4. Okay, and then I have analyzed the loading. We have all this, and then uh, uh, at the roof floor we have one slab, which is to hold the water tank. Okay, this is the specification of the slab. Okay, we got the two-way slab, and for the case 2. Okay, and then we calculate the water tank loading. Okay, near at slab that we have analyzed before this. Okay, the capacity of the water tank is 150 gallons, which is 568 liters, and then the diameter is this, and overall height, width, and slab panels is like this. Okay, and then load on water tank. First we need to find the GK, and we need to find the QK, and we got this for the water tank. Okay, and then load on slab. We have calculate, and then we got the GK for 4.11, and then what QK 0.52 of water load for QK. Okay, and then for load on beam, which is a distribution of load is from slab to beam. Okay, first we have to take a look at W1Y. Beam W1Y, if we look at this figure, it's like here. And then we have W1Y, we have W1Z, we have W2Y, and then we have W2Z. Okay, for your information, the horizontal beam like this is Z axis, and then for the vertical beam is YY axis. Okay, we look at this again. Okay, for load on beam W1Y, which is we have get a two-way slab. Okay, and then we calculate the GK 6.9191, and then we calculate the QK. This is QK 0.64, and then we calculate the N. And then for load W1Z, uh, okay, we have analyzed the two-way slab. Okay, load transfer from slab, right? And then we calculate the GK 6.91, and then QK 0.64. Okay, and then the total design load N, which is 10.929. Okay, and then load on beam W2Y, and then we get the GK 1.875, and then for QK we got 0, and then we calculate N, we got this, and then we calculate the last beam, which is W2Z. Okay, we got a GK 1.875, and then QK is 0, and then also the same, the beam like at, at the top. Okay, the specification of the first floor. Okay, this is a figure of the figure plan of first floor. This is the critical column, column B4, and then we have analyzed. This is the slab that transferred load to this three beam. Okay, first we have a beam W1Z, and then W1Y, this vertical beam, and then W2Z, this horizontal beam. Okay, and then these are the slabs that transfer the load. Okay, and then for the loading we calculate all this, we analyze this, and then this is a load, imposed load from these three slabs. Okay, these three slabs, and then the column size is 202. 200 times 200, and then the beam size is 500 105 115 times 450. Okay, and then these are the the specification of the slab, and then we calculate the load on slab. Okay, we calculate the GK and the QK from slab. Okay, load on beam, that which is the transfer the slab transfer the load to the beam. Okay, and then we calculate the for beam W1Z, we calculate like this. Okay, and then we get the GK 24.88, and then we got the QK 4.61, and then we calculate the N, and then for the W1Y, okay, we analyze like this, same like before. Okay, we got the GK and QK, and then we got the total N. Okay, and then for the lab W2Z, same like before. Okay, and then we calculate the GK, and for the QK, and then we calculate the total N. Okay, and then we do the specification on ground floor. On ground floor, we analyze the same column, which is a critical column, column B, and then we got like this. These are the slabs. These two slabs are transferring the load to these two slabs. Okay, we label it. We label this slab is GS1 and GS2, and then these are the beam that attached to the critical column W1Y and then W2Y. There is no horizontal beam at the ground floor. Okay, and then we do the load analysis. And we calculate all the loading. Okay, these are the specification, and then we calculate the load on slab, like just before. We find the GK, QK, and then we calculate the load transferring from slab to beam, W1Y. Okay, we calculate GK, the total GK of all of this load that transferring to the beam. Okay, to the beam W1Y, and then we find the QK 3.52. Okay, and then we calculate the N using this formula like before. We got a 31.08. Okay, and then we calculate for load transferring to the beam, W2Y, and then we calculate like before. We find the GK. Okay, and then we find the QK, and then we calculate the N just like before, 31.08. Okay, because of these two beams have the same length, which is 1,500 millimeter. So the load transferring from slab to the beam, from these two slab to the beam, is like the same. And then so the calculation of these two beam is same. Okay, and then we calculate for the axial force. And then for the column for B, the size of column is 200 times 200 millimeter. Okay, this is y axis, and then z axis. Okay, these are the length of the beam. Okay, all of the beam that attached to the critical column, based on all the floor. Okay, this view is more clear to show to all of you about the critical column that attached with the beam besides it. Okay, these are for the first floor. This is for the roof floor, and then this is for the first floor, and then the last one is the ground floor, and then this is the pad footing lah, pad footing and stump. Okay, these are the height of all the floor. This 3.6, 3.5, 5, and 1.5 for the ground. Okay, and then we tabulate all the load that transfer, okay, that transfer to the column critical, and then we got like this table. Okay, this table are showing us the all the beam all the beam that transferring the GK and QK, okay, to all the floors. Okay, we calculate the max, okay, using the formula design load, okay, and then this blank is because of there is no beam here, okay, and then we calculate the N, which is NED actually, for each floor. For the first floor to roof, we got 45.86, and then for ground floor to first floor, we got N 130.85, and then for footing ground floor, we calculate and we got 48 and 65 kilonewton. Okay, and then we need to calculate the bending moment for the ZZ axis first. Okay, we calculate the K, which is K is stiffness of the column, stiffness of the all the beam that attached to the column, and then we calculate, okay, calculate using this formula K, and then we transferring this data to use in this calculation. We calculate the fix and moment, okay, and then we calculate the moment in column. uh, at the roof floor, there is only a column below the beam, so there is only one moment column, okay, and then this is for the next floor. Yes, actually, okay, this is the upper column, and then this is the lower column, and then we calculate like same like before. We calculate the fix and moment. Okay, we calculate moment at lower and moment at upper, and then we got this, and then we transferring all the data moment on this figure. The moment of the column MZZ. Okay, this is actually for the ground floor, because of for ZZ axis, we don't have any column, so there is no moment transferring. Okay, then we proceed to YY axis, and then we calculate like the same as before. We calculate the stiffness, and then to use in this calculation, okay, this calculation is same like before. We analyze each of these beams, okay, analyze all the moment each floor, and then we get the moment diagram for the column like this, okay, like this for the MYY. Okay, and then we need to proceed for the column design. Okay, before this, just calculation for the analyzing the load that transferring to the column. Okay, and then we need to design the column that are suitable for to resist all the loads that transferring from the top. Okay, and then when these are the detail of the column length is actually 3.55, column size 100 and 200, beam size 150, 450, FCK, FYK, like same. Okay, and then we need to calculate YY axis. We calculate the beam column detail, beam detail, okay, and then we calculate the I, which is a moment of inertia. Okay, we got this value, and then we calculate the LO, which is effective length, using this formula, and then we calculate the K, and then we calculate K, and then we use this formula to calculate the effective length, and then we need to calculate the slenderness actual y at y axis. We got 57.6, and then we need to calculate the lambda limit, slenderness limit, using this formula, okay, and then we need to calculate NED, N, which is NED over AC FCD, we got this, and then we calculate the lambda limit y axis, and then we got this, and then the lambda limit must be larger than lambda x y lambda actually y, because of we need to make sure that we got the short column for this design, because of in our syllabus we just cover only for short column. If the lambda actual is larger than lambda limit, we will get the slender column. Okay, and then we proceed for the zz axis. We need to analyze like the same as before. Okay, we need to analyze that our column is short for the zz axis, and the last one we got the column is short because of lambda limit is larger than lambda x, slenderness. Okay, we calculate like this, and then after that, then we proceed to all the specification of the column, and then this is the specification, and then we calculate the like usual. We calculate the sin norm. Okay, sin norm we got a 30 millimeter, and then we calculate the design moment. Okay, we calculate the design moment for zz. Okay, we calculate med. So med actually we need to analyze maximum in these two moment. Okay, first moment 2, m dot 2, and then moment mean. Okay, m dot 2 we got this. Okay, we got this, and then we calculate the moment mean, this, and then the larger value of these two moment, we will use the as medz. Okay, and then same like zz axis for yy axis, we calculate for med. Okay, same. We got the med equal to m naught 2. M naught 2 is larger than m mean, so we choose m naught 2 as medy. Okay, and then we calculate m prime y, and then we calculate using this formula. We calculate beta, we calculate h prime, b prime. Okay, and then we calculate this. We got a 6.94 kilonewton meter moment at this, and then we calculate d, which is this. D actually is the same like h prime. H prime like we get from this, we just use it, and then d over h we got a 0.77, and then we need to calculate okay, n over bh fck, and then also m bh squared over fck, bh squared fck. Okay, we got this value, and then we need, and then yeah, we need to calculate the as required. Okay, we first we got 0 from the chart. Actually this formula this we referring to the chart, we got 0, and then we just use as required. Just as required, we take 4h20. Okay, and then we calculate the s mean using this formula. Okay, and then we take the s mean using this formula, because this is larger than this value. Okay, and then we calculate the s max. So what we provide as at the top, this is more larger than s min, and also is lesser than s max that we calculate this, so it is okay. And then we proceed, and then we need to proceed to calculate the length. Okay, diameter maximum between 0.25 diameter bar, and then 6 millimeter. And then we use 6 millimeter, which is larger than 5 millimeter, and then we take this, okay, to as the link, okay, for the column. Okay, and then we need to check the biaxial bending. Biaxial bending actually, we need to identify the EZ and also EY. What is EZ and EY? Actually, is the moment as Z axis and also Y axis. We need to divide it by the N, which is the load transferring at the floor from the floor. Okay, 130.85. Actually, this is the load transferring from the floor. Okay, we take this as an ED, and then we divide it, and then we got EZ for the both axes, and then we calculate this, and then we need to consider it as uh, because the value of 2 axis is larger than 0.2, we need to consider it as biaxial bending. And then we need to calculate the lambda y over lambda z, and also vice versa. And then the value is 2 is larger than this value, and then we need to ignore biaxial bending. So if these two rules is passed, if we got ignore biaxial bending and ignore biaxial bending also, we just need to calculate for unit axial, which is we need to calculate only for one axis. So then we got a 1, we need to consider it as biaxial bending, so we need to proceed to calculate as biaxial bending. Okay, and then we calculate the reinforcement like this. Okay, and then we calculate the S max. Okay, we need to use this formula, the lesser of these two. Okay, and then we use 200 because 200 is lesser than 400 millimeter. Okay, and then we need to check for biaxial bending. Okay, all we use are 4H20. Okay, for the steel we use this type of steel, and then we calculate DH to use in this chart. Okay, for the in the chart we got this value. Okay, and then we get the MRDZ equal to 42. Okay, and then this is for the Z axis, and then for YY axis we calculate as the same like this. Okay, this same like the chart. We need to refer to the chart. Okay, and then we need to calculate the NRD, yes, which is AC times FCD times plus SFYD, and then we use this formula. Okay, and then we get this value, and then we need to divide NED and total divide by NRD, and then we got this value. Okay, so we need to use A as 0.98. Okay, because this value is smaller. Okay, and then we proceed to calculate the imperfection, and then we calculate, and then this formula we need to calculate all the requirement, and then we have to make sure that the value of after we calculate in this formula must be lesser than 1 to make sure that to check the biaxial bending is passed. Okay, then we proceed to detailing. This is the detailing. Detailing of the column. Okay, this is the roof floor, and then this is first floor, then this is ground floor. Okay, this is ground floor, and then the column is the dimension of column 200 times 200 millimeter, and then we use these types of bar, and then yeah. Alright, after we have do the detailing, we need to do the taking off of the column. Okay, taking off column, and then we have taking off. using this table, timings, dimension, quantity, and also description. We taking off all these materials. We taking off concrete reinforcement. Okay, we got this value. We use grade 35 of this column, and then we calculate the reinforcement. We got this value. Okay, for h20, and then we calculate the link. Okay, and then we need to analyze the link on all the floor. Okay, for the types of link we use the bar h6 250, and then we analyze for this roof first floor. Okay, and then we analyze for the next floor. Okay, and then we got this value, and then yes, on this. Okay, right. Okay, and then we proceed to the formwork. Okay, only for the two floor. Okay, we got this value, and then we have prepared the BQ of the column, of quantities of the column, and then we have provided the BQ based on the latest rate of all these materials. We use concrete G35 reinforcement, this type of reinforcement, and then formwork we use a 6mm thick plywood. Okay, and then after we calculate all this BQ, we have a total bill for the critical column. We get this value 300 Rn 322.77 cent. Okay, I think that's all for the taking off and also BQ of the column. We proceed to the next video. Thank you.